Now, a huge welcome to Cultivate Africa, your virtual talk series designed to create a vibrant Pan-African community for everyone passionate about agriculture. Our mission is very simple. We want to bring together farmers, agronomists, researchers, and students to share their knowledge, discuss pressing challenges, and explore the innovative opportunities shaping our continent's soil-friendly farming. And now tonight, for the official beginning of our event, we are truly privileged to have with us Mr. Jackson Giroux, who is the Deputy Principal for Technical Training at College of Sustainable Agriculture, East Africa. Jack has 12 years of experience in agroecology, and his work focuses on practical solutions for soil health, restoration, crop diversification, and sustainable food production in changing climates. Jackson is one of a kind because he holds the uniqueness of being our first speaker on Cultivate Africa. And since then, we've had 7 excellent sessions, and thank you, Jack, for setting the bar very high. He will be unpacking for us the practical irrigation and water conservation tips tonight. Now, please join me in giving Jack a very warm welcome. And Jack, the screen is all yours.
Thanks so much, Mr. Robert. Good evening, everybody, and welcome to this session. Thanks to all the participants. And I'm going to take you through the practical water conservation tips and irrigation tips. As from the introduction, thanks so much, Mr. Robert, for giving my small, how do you call it, introduction on what I do. So today, as we start this conversation, I would want to just say that we are in a very difficult times, especially the African farmers, because of what is happening as far as water availability is concerned. You know, in our community, some of us, they have a statistic of about 70% who are farmers. And water conservation is an integral part to do first, to ensure that at least we can keep our population growing and our urban centers moving on. So today, as we delve into this topic, the first thing is to ask whether we have enough water in this world, and how much is it available for human consumption. My presentation will have to, how do you call them? 2 sessions. Whereby the first session, I'll be looking on the water conservation, even before we go to the irrigation tips. And as we all know that water is available in a lot of forms, but then what matters most is how much we can be able to utilize. So today as your host, I'm Giroux Jackson, Deputy Principal in SAIA, that is a College of Sustainable Agriculture of East Africa. I'm in Kenya, and I'll be your resource person today. So, the first question when you talk about water, the first question is to ask whether we have enough water and we have a reason to do this conservation. And when you check on the world water availability, there is a good distribution whereby in our own planet, the water covers about 71% of our Earth's surface. And this water is found in the oceans, rivers, lakes, glaciers, groundwater, and the atmosphere. And funny enough, it's only the small fraction of this water which is available for agricultural or for human consumption. And what are the percentage of this water? Let's see. So out of all these water, the world water, 97.2 is found in the seas and ocean, which means that it is salty water, and only 2.8%, which is available as fresh water. And out of these 2.8% is what the out of these 2.8%, 68.7 it is like ice. That percent is on the ground. The other one is 0.9% is a permafrost, and only 0.3%, which is on the surface. Why am I giving these statistics? I think I need to remove this. Allow me to drag. Okay, I can drag it on one side. Thank you. All right. So only 0.3%, which is surface water. And out of this 0.3%, as you can see from the statistic, 87% is in the freshwater lakes. And fresh water in the wetland is about 11%, and the rivers carries 2.8%. I think with these statistics, there is need to ensure that at least we conserve water, whether it is through replenishing the groundwater or ensuring that our rivers flow by conserving the environment through afforestation. So what are the needs, what are the uses of water? And I'll say that I'll divide it is divided into three categories, whereby one is the biological importance, environmental roles, and human roles. And human uses. As we know, in biologically, we maintain, the water is used to maintain our hydration, metabolic processes in our bodies. It regulates our body temperatures and provide habitat for aquatic life. The environmental role, obviously, is about regulating the earth climate through heat absorption and circulation. Drive water cycles, that is through evaporation. I'll call it hydrological cycle. We all know about it. And it supports the ecosystem and biodiversity. For human uses, used for drinking, agriculture, which carries a big chunk, percentage of how we use the fresh water. And still through transportation and energy generation. So when it comes to the conservation tips, why conserve water? I think the first thing, that's the best question. And how do we understand by water conservation? By definition, I'll say this water conservation refers to the prudent management and preservation of water resources to ensure the sustainable use for present and future generation. So it's not only about us, it is mostly about today and our future generation. And when we talk about the water conservation, we are looking at we are looking on ways on how we can ensure that we use the minimum or the most efficient ways to utilize water. And one of them is the reducing the wastage and improving efficiency in water usage, which means that we have to implement strategies to replenish and protect water resources. So all these water conservation ranges from simple household practices like turning off your taps, advanced techniques advanced techniques such as rainwater harvesting, drip irrigation, and wastewater recycling. When it comes to those topics of water conservation, I think we have a few units or other ways of ensuring that we do conserve our water. And one of them is the rainwater harvesting. We'll be looking into it on how to achieve that. Watershed management, which means that we have to take care and protect our forests and water catchment areas to ensure that our rivers keep on flowing. This also means that we'll have to control soil erosion to ensure that our groundwater percolate enough to replenish those groundwater reservoirs. And we'll be also looking on the efficiency in irrigation techniques, bearing in mind the amount of water which is available for all these activities. And the other one will be on the gray water recycling and the reusing, which also take us to the afforestation and soil conservation. When we talk about the afforestation and soil conservation, I think there are some few things which we also need to consider, because afforestation and soil conservation always influence weather patterns, reduces soil erosion, and maintains groundwater recharge. So when you are looking about the element of water conservation, is not just water as a component by itself. It's a series of small things which we need to bring together to make this great endeavor viable. And afforestation and soil conservation is a big part of water conservation. So the approaches are critical globally, where freshwater scarcity is intensifying due to climate change and urbanization. So we're going to check on the approaches on water conservation. And the first approach is to ensure that at least in our household, that's where we need to start, even go before we go to the bigger part, the bigger picture as far as conservation, water conservation is concerned. And we start by the simple things like turning our taps when brushing teeth and washing. If you go to the statistic, you realize that you fix your pipes and turn off the taps when brushing your teeth, you'll be saving up to about 45% of the household water usage. And the use of water efficient appliances, where I think all of us, we always look on the water appliances, or rather the household appliances. Nowadays, they are coming with the ratings and how much of water they can save. So everybody is becoming smart, from the manufacturers, engineers, and all the people who deal with this product, to ensure that at least we save a drop of every water. And the other one is on the usage of reuse of gray water from sinks, showering, laundry. And nowadays, there are a lot of technologies which involve reed bed systems, especially if you have interacted with the permaculture designers. You see they already have a reed bed system, which is mostly for the small scale farmers, or rather for household use. So these are some of the practices as far as water conservation in the household levels are concerned. I think there are more. I didn't put all of them in the slides, but at least these ones are to give us a more insight on what we are required to do. So on the agricultural methods, statistically, agriculture is one of the largest consumer of fresh water. It goes up to 70%, to ensure that at least we have that coffee, we have those vegetables in our tables. And in Africa, this consumption goes up to 80%. So how do we ensure that at least we don't waste the little resources, which is 2.8% of world water? And one of them is to ensure that we practice, or rather we go on something we call can't remember the word, but it's more of a landscaping, xeriscaping, which involves a drip irrigation, choosing of right crops, mulching your soil, and farming on a contour or terraces. And the reason why we use the irrigation system like a drip irrigation is believed to save around 50% of water. This is because it delivers water direct to the plant root, and it helps reducing the water evaporation. And with that savings, the exact about 50% can be redirected on other places, or rather can be used to maximize agricultural practices. Mulching is one of the best known practices as far as farming is concerned. It always ensures that the soil retains the moisture and reduces evaporation too. Crop selection, we all know, depending on our climatic zone, or rather, climatic or the weather pattern on where we come from, there are some crops which thrive in those areas very well. So which means that, for instance, if you're in a dry areas, you need to adopt on the type of crops which do very well, or rather, which require minimal amount of water. Which means also that you can grow more of a crops which are like cereals, especially the how do you call them? The millets, which don't require a lot of water. So crop selection is very important when it comes to agricultural methods, which are involved in ensuring that we conserve our water. Contour farming and the terracing, we know that this one help on the stopping the flow of water down the hills, and it used to, first of all, to stop, spread, and then make it sink. With doing so, this one will prevent the runoffs and enhance water infiltration, which will help us on ensuring that at least we replenish the ground waters. Still on the community and the urban approaches, nowadays our urban population is growing, and is as a result of rural to urban migration. And this one is giving a lot of pressure and the water supplies, which means that we need to start from our own community, ensuring that we harness enough water from rainwater, because this one comes at a specific time. You need to ensure that at least we have enough storage and well-designed farms to ensure that at least we maximize the flow rather than letting it go down the hills. As it goes down the hills, it means that it carries our topsoil, which also affect our crop production. But ensuring that at least we design our farm whereby we can spray the water, stop and spray the water, we can ensure that at least it sinks to replenish the groundwater reservoirs. And the other one is on the smart city planning. As I said, everybody is on the rush to ensure that at least our urban areas and everything of our appliances which we use at home, they conform to the energy saving and water conservation processes. And this one, when it comes to smart city planning, it means that we have to incorporate green spaces and permeable pavement to enhance infiltration. If you have been in urban areas, in which I believe all of us we have been, there are some designs, or rather the drainage system, especially in Nairobi, in our capital city, Kenya. Last few weeks, we had a storm, which really gave us a challenge, which means that it's not only the farmers who need to conserve water, but even the city planning need to incorporate this to ensure that at least we can maximize and direct water where it is required, the excess water from the towns. In some areas, like in the no man's areas, the no man's lands, the pastoralist community, their building do not conform to a form where they use iron sheets. So due to these designs, the rock catchment is one of the best ideal practices where they can do to collect the water just as the roof, just like water on the roof of the buildings. These methods are viable. These methods are very viable in areas of arid and semi-arid areas. So it all need the design again on ensuring that at least the water which strike those stones always end up somewhere or already directed in farm designs whereby we'll ensure that it goes into the underground reservoirs. Still, remember in those areas, arid and semi-arid areas, the rain are a bit erratic, so it's good to ensure that these communities, they have the storage, not only the designs to ensure that there is good percolation of the water, but also to ensure there is enough water harvested when it is when it is adequate for future use when the climate is not that favorable. And the other one is on the check dams and percolation tanks. These are some of the things which we always encourage farmers, especially the small scale farmers, to ensure that they do so. And these are check dams. It's only the check dams, but we have what we call the sand dams, which it's just a barrier of a seasonal river. And these barriers always ensure that at least there is enough water which is harvested behind those barriers, which can be reused. When you dig some sand out of it, you can access water which can be used for domestic use. And the other one is on the wastewater recycling. This one is from the sewage, and also they're using irrigation systems, especially for those who have adequate water. As we said, there are some places which have more water and others which don't have enough water. So the wastage, water wastage should be discouraged at all cost. In the industrial practices, we'll be talking about the closed loop water systems, especially on the cooling system. You know, in the industrial processes, you can see some chimneys which always give steams. In most cases, that is water escaping. So this closed loop is they are designed in a way that the water, all those steams can be condensed and recycled again to the industrial processes. With that, we can ensure that at least we save enough water, or rather we can reduce the extraction of water from our ecosystem. Cooling towers optimization, again, you know, in some of the industries, due to the amount of energy amount of water which is used, the cooling towers, again, they can be used. These towers, you know, due to the interaction with the atmosphere, the cooling takes place, and those steam again, they are recycled to the factories. Again, the process redesigning using dry or semi-dry manufacturing techniques where possible. So these are, again, ladies and gentlemen, these are some of practices which can be used in this industrial scale to ensure that we reduce the amount of water which we are using. In comparison table, I try to compare the amount of water which is used and the methods involved. And you can see household efficiency. This one starts with the individual utilization. Sorry. Household efficiency, whereby it is mostly on the scale is on the individual utilization of water. The benefit of it is it reduces daily wastage. Remember, we already give some tips on how to reduce the wastages, like closing your faucets and not using the running water when you're brushing your teeth. But also this one has a challenge because it requires a behavioral changes. On the drip irrigation, as I said, we save about 50%. Initial cost of installation is the biggest challenge to the farmers. But when you get that one right, you can see the amount of water which you're supposed to save as far as the crop production is concerned. Rainwater harvesting, this is a collective duty to the community and the urban dwellers and the designers, which will provide supplementary water, especially when on the dry periods. And the challenge, the biggest challenge is that the need for storage infrastructures. Those ones have to be put in place to ensure that at least we reduce the amount of water which goes into waste, especially during the rainy season. Recycling of water. This one is also on the industrial and urban, which reduce the demand on fresh water sources from our rivers. The challenge comes when it comes on the treatment, which attract a certain budget and which need to be covered by the municipal or rather the companies or the parastatals who are tasked by, they are tasked with that duty to ensure that the water is recycled. And for agricultural community, which it involves mulching and again, the crop choice, depending on the places where we are, which will help in improving soil moisture and it's a bit limited by crop market. Well, all these tips which I've given upfront, they have some risks and challenges which we have already highlighted, but this is just a summary whereby some of them require high upfront costs for technologies like drip irrigation and watershed wastewater treatment. They also need maintenance requirement for rainwater harvesting systems, which also involve the redesigning of our farms, building of those tanks, and especially the ferro tanks, which are more durable compared to the plastics. In our college, we always encourage farmers to do the ferro cement tanks, which are quite durable, and they will reduce the amount of, how do we call it, repair vis-a-vis the plastics ones, which are prone to damage or vandalism from the other community. And the biggest challenge is on the community adoption barriers. Success, these ones depends on awareness and collective action. It also means that you have to do the policy intervention and the awareness campaigns. You know, humans are rational, and we have our own ways. And the more you try to give them these, you try to endorse of these practices, some of them become rebels. But with the enough policy intervention and the awareness campaign, the work becomes a bit easy. Climate variability may reduce the effectiveness of rain-fed conservation methods. Yeah, sometimes there is enough rain, others they are not. And at the same time, when there is enough, there is much of the rain, these dams, water ponds, sometimes they get sealed. So still, those are some of the challenges which you face as far as water conservation is concerned. We still have some actionable steps on water conservation, and one of them is to promote rainwater harvesting by providing tanks or encouraging farmers to build these tanks. Some of them, and as I said, we always encourage them to do the concrete tanks, which are more durable, and once installed, there will be more. They stay longer without much maintenance compared to the plastics ones. And rainwater harvesting through construction of dams, water ponds, and sand dams. I already explained the water ponds and the construction of the dams to ensure that we can improve and maximize the water holding capacities, which can be reused or can be used during the dry seasons. Scale up drip irrigation in dry farming region, which also means that we ensure that we cover our soil much to reduce the evaporation. It also calls for action for afforestation and forest conservation to ensure that at least the water, we can replenish our groundwater. We also need to encourage grey water reuse in urban housing estates. Nowadays, I think is a requirement, especially I'll give an example of what I know about Nairobi. There are no much of how do you call it? The sewerage system is there is you have to connect your house, rather the big houses, to a sewerage system, which is well monitored by the government, because to some extent, some people didn't have all these systems. Some of them were directed to the rivers, which means that the people on the lower side of the river, they get the water get contamination. So the grey water use in the urban housing is the paramount to ensure that at least every person gets their share and in the right state. As I said, community need to be involved, and in this you have to support them, community water committees, to manage share resources sustainable. And in the college also, we always ensure that to ensure that the water, or that the community have this water sovereignty, to ensure that they know the costs, not just utilization, the costs of installation and maintaining those systems. So in most cases, those systems, we call them wenyeves, they are small water use schemes, which are formed by around 100 farmers within the people who live along the rivers. So these 100 farmers, they form a group which can monitor and ensure that at least they take care of the riparian lands and report any unwarranted activities which might be done by other people in those areas. So these are actionable steps on water conservation. I think I'm coming to the end of the water conservation. Not really, but I'll just echo on the importance of water conservation. As I said, our climatic conditions are changing, and we are having these erratic rainfalls, and to some extent due to the depletion of the ground cover, which lead to the depletion of groundwater. And again, the reason for conservation is the increased demand from the agricultural and industrial and urban areas. So I think I will welcome any question on that topic.
All right. Thank you, Jack. I think by looking at the chat box, there are no questions in the chat, but I can ask a question, and we will be waiting for anyone in the audience that has a question. If not, we'll keep on with the presentation, and the questions will come later. And before asking a question, I am intrigued by what you just said. You know, we always talk about how risky African agriculture sector is currently, and what it may cause in the future, without really explaining why. But for you, laying out the fact that agriculture consumes up to 80% of fresh water, and the fact that we are running out of fresh water with the current global challenges like climate change and urbanization, I think now makes it more sense on why and how our agriculture sector is at risk. And my question is, you just talked about it as you were ending the presentation on water conservation, how you do it at the College of Sustainable Agriculture East Africa. I would want you to explain more on. You talked about something called Wanyewezi, something like that, but I would want you to explain more on if someone, let's say an institution like yours, a similar institution, or an upcoming organization wants to put up some practical steps on conserving their water, what would be your advices considering what you do at the college?
So thank you, Bwana Robert. Yeah, when we talk about the wenyeves, we are talking about irrigation systems which are owned by the farmers. And as I said, mostly it is more practical in near the forest where there is enough water. And what we do is that to ensure that in order to create and lobby and create awareness to the farmers around those areas, we always ensure that we educate them, or rather we train them on, first of all, creating the awareness of how much water we have, how many people depend on this water, and how many rivers we do have. So the moment whereby we have, remember, crop production is one of the agriculture is one of the main employers in our society, which goes to about 70% of the small scale farmers. And this farming requires resources. And one of those resources is water, which is scarce and inadequate for all the practical part of water as far as water is concerned. So what we do is that we bring the farmers together, whereby everybody is accountable. They are like policing on each other, whereby we tell them this is the amount of water which can be utilized by this community and at what time. So with that one, they are consciously aware that there are some people somewhere who are downstream, like in coast, who would really require that water to reach in those areas. Because if we do the blockage, it means that some of these peoples will not get enough water, or will not get any water at all. So what we do is that to ensure that at least when there is first of all, we encourage on the designing of this farm, whereby the minimal amount of water is required in those areas. And which also means that the amount, the type of crops, it also involves the type of crops which you grow in those areas. And with that, we save considerable amount of water to ensure that this river keeps on flowing to those areas. So it's a deliberate way of training to ensure that the farmer gets to understand what really means to on water conservation.
Right. No, it makes more sense. I think we can go on with the presentation and the questions will come later.
Okay. So I'll dig into part 2, whereby after knowing the tips of water conservation, how do you do the utilization as far as irrigation is concerned? We have a lot of techniques. I'll just highlight some of them. And at the end of the presentation, I'll be explaining, or rather you'll have a slide which gives details on what kind of irrigation to choose. Yeah, because to some extent, some of these irrigation tips, they are not practical in some areas. They are not practical due to either the topography of the land, type of soil, and the type of crops which are grown. So it's not just the irrigation, but the practical tips which favors all the farmers or the people who are doing the irrigation. So irrigation simply means the artificial application of water to the crops, and it is done when there is no rain, or as a supplement to crop in case precipitation does not bring sufficient water. And this is a challenge to all of us Africans, because our farmers, we have a limited amount of water, especially in most part of the continent. Is either arid or semi-arid areas, and which means that it doesn't mean that it also means that we need to do the practical to do the crop production, but we need to do the irrigation. And as I get to these slides, I'll be mentioning some of the practical irrigation ways on how to, which can be utilized in those areas. And type of irrigations, I'll start with the surface irrigation, which means that the water flows over the soil surface by gravity. And it can either be delivered to the crops through furrows, basin, or border irrigation. The furrows, as it can be shown by the pictures here, this is how it is done. It has the advantage because they are simple. Every farmer will be able, they just require the holes and they dig around their farm, design it, whereby the water can go through the furrows or the basin. It is low cost and is suitable for flat land. Again, as I said, all the irrigation systems, they have to conform or fit with the topography of your land. So this system, service irrigation, it requires a suitable flat land or relatively flat. The disadvantage is there is high water loss, evaporation and runoff. Remember, still it can cause the excess water due to breakage of those basins and the furrows. It means that the soil erosion might take place. We have the drip irrigation, the most advanced and the most ideal, where the water is delivered direct to the plant through emitters. These emitters, they emit water in droplets at the base of the plant. And they also depends, I think I've interacted with the drip irrigation systems, and they all depend with the available water and the crops you grow. There are some which emit, those emitters emit 1 liter per hour. There's the others which emit half a liter per hour. And there are some which even emit a quarter a liter per hour. Some goes up to 4 liters, especially the one which are used to grow trees. And again, as I said, it depends with the availability of water, because if you are going for a drip which discharge 4 liters per hour per emitter, per those emitters, it means that you'll be required to use a lot of water. And they are best suitable for fruit trees, vegetable, and the most ideal place to use this is on the dry land farming. It has advantages which saves up to 50% water, reduces weed growth, and improve yields per acre. The disadvantage of it, there is high initial cost, and it requires maintenance. It requires well-filtered water, because any impurity which passes through the tank to those emitters, it means that they'll be blocked. And unblocking them, they require considerable resources. In some farms, they use the sprinklers. The sprinklers, there are some which are using pivot sprinklers, the large-scale farmers. And it ranges even to the small-scale farmers who use the one sprinkler, depending on the type of crops you are growing. They are best suitable for vegetables, the lawns, and the cereals. Advantages, it covers large areas, especially the pivot irrigation system, sprinkler irrigation systems. And the main disadvantage, the most undoing, is that there is a lot of evaporation losses, weed interference, and as I said, they are crop-specific bound. For instance, if you are doing a lot of, if you are doing vegetables, especially the tomatoes, that you do this type of irrigation, there is a high risk of fungal infections. So as we choose the type of irrigation, you need also to consider the type of crops which you are growing and the soil type. We also have the subsurface irrigation. This means that the water applied below the surface by the pipes buried. It has the advantage and disadvantage. And the one disadvantage is the blockage by the soil. And they are very expensive in installation, and they are difficult to maintain again because they are under the soil. It also means that we need to take care of how do you call it, the vegetation growth, because the more, they need manual weeding, it means that if you're using hoes, it means that you can cut those pipes which are below the soil. But it has also the advantages. They are very efficient, reduces evaporation, and they're ideal for high valuable crops. So the valuable crops, which fetches good or the premium prices, they also come with the shares of difficulties, especially on the maintenance and the installation of those systems. We also have the Trido pumps irrigation. These are the manual ones, which are more of pistons, whereby they are operated by someone by stepping on, as they are being shown on the picture. There is an illustration, as you can see from the screen. In Kenya, these are technology which has been embraced by the small-scale farmers and who are near the water bodies, the fresh water bodies. The disadvantage is that they are limited to area coverage. They require about 2 persons to operate because one will be operating the piston part of it, and the other person will be using the hose pipe to irrigate. They are labor intensive. Again, they require a person, an operator. But the good thing with them, they are low. They are low in costs, and they are suitable for small scale holders, which means that all our small scale farmers, they can embrace this one and who are quite near to their water sources. Okay, here there is a comparison table which I prepared on the type of irrigation system which we choose. And the service irrigation, as you can see, the efficiency, I'll dwell much on the efficiency part of it and the cost and the ideal use. So the service irrigation, you can see they are medium in efficiency, the low cost as we have discussed, but it can only be utilized by the small to large scale. And as I say, they are ideal to relatively all flat lands. Drip irrigation, suitable for dry lands. As I said, it saves over 50% of water. Sprinklers, they are crop bound and they are most ideal for cereals. The reason I put a cereals, it was deliberate, as I have explained. Some of the vegetables, due to fluctuation weather patterns and day and night, you know there is that dew in the morning and a bit of dry period, which are very good ground for the fungal infections. So the sprinklers also has its own challenges, but it can also be used in the scale of medium to large scales. Sub-service, very high in efficiency, cost is quite high, and they're specialized, not only for any other crop, but the one which are highly valuable and which fetches a premium on their prices. Traders, again, manual, that is the most undoing part of it, and it requires someone to operate. The cost is very low, and it can, unfortunately, it can be used in the large scale farming. So as I said, in this slide, we are checking on the factors to consider, and one of them is the water availability. As I said, you can't use sprinklers in the dry areas where the water is scarce. You need to be more creative on choosing your type of irrigation. Again, the soil type, remember some of the types have a high holding capacity, and it also means that it depends with the type of crop which is grown in those areas. For instance, if you can't use the basin, if the water holding capacity is very low, and it also means that even in those higher holding capacity soil, it means that you need to consider type of crops which need to be grown, like the paddy rice, need a lot of water. It can be used on the basin or the furrow irrigation. And again, we need to find the energy source. And the most ideal is that if there is a gravity ways of irrigation in the farm, or if there is a solar energy utilization. Again, remember, your returns will be determined by the amount of resources you use, and energy sources are some of the ideal part which you need to consider. So solar energy and the gravity as we irrigate might be the most ideal compared to use of fossil fuel, which also contribute to the destruction of our ecosystem. So in my conclusion, I'll say that we need to consider the efficiency in irrigation to ensure the sustainable agriculture and food security, and which is the main reason why we need to conserve water to maximize the food security levels in our society. My call for action is to save water to secure tomorrow. Remember, as we said, is a prudent management and presentation of water resources to ensure there is sustainable use for present and future generation. So saving water, we are securing our tomorrow for the generation to come. And I think this brings me to the end of presentation. I tried to use some sketches to give the infograph on the practical irrigation methods. And as I see, there is a drip irrigation, subsurface, how they can be utilized, sprinklers, and also choosing the right system. This one explain all the slides which I've shared at a pictorial glance.
I was about to ask him, of all the, he might have touched on it, but I wanted him to clarify on all the types of irrigation he mentioned. One that is suitable for small scale farmers, and considering that small scale farmers might vary depending on the location. A small scale farmer in South Africa is not a small scale farmer in Rwanda, and I've seen so many drip irrigation. We used to use drip irrigation at Rika, and I wanted him to elaborate on what he thinks are the best practices for small scale farmers doing the irrigation methods. Hopefully he will
Mhm.
join in back.
Yeah, but Robert, in the meantime, there's one
Mhm.
irrigation system I seen he showed us. I think he called it surface irrigation, where you
Mhm.
draw laws between, you build
Yeah.
bridges in your garden, then you put laws, that's where you direct your water. I think that one could be suitable for a small farmer if they are able to direct the water from the water dam directly to the farm. So it's as simple as drawing laws each between
Yeah.
the bridge. There's a law that contains water. Yeah, I think it was
Right.
good. Let's see if there's somebody else who can integrate and say what they think on their own. Yeah.
Right. We have a hand from Johan. Johan,
Hi,
okay.
Robert. Yeah, it was very interesting to me the chart that Jack left us on with the different irrigation methodologies. I would also like to encourage people to explore subsurface irrigation. In my experience, I've implemented it in a very simple way, channeling the grey water from the house into raised beds with, as Jack said, with high value crops. And of all the methodologies that I've used, including drip, it's by far the most successful and the best reaction from the plants. As it indicated, there are no evaporation because the water goes straight to the soil, straight into where the roots are. It just seems to cause very, very happy plants. And you get much more. They say you get bang for your buck, but you get real good value for the water that you put into subsurface irrigation. So it might be a little bit of, if you're going to do it at a larger scale, not even a very large scale, it might be a bit of trouble to install. But I would say it is something to really consider in terms of the value that you get back from it.
True. Yeah. So Jack, as I were kicked out of the Zoom room, we discussed on different types of irrigation that you mentioned, and the question at hand was, of all the irrigation practices, what would be suitable for a small scale farmer, and with the consideration that the scale of farming varies depending on the location. And then Johan came in and talked about subsurface irrigation. And maybe something I can ask you on that is he mentioned something about the cost of installation and all. If you have experienced it in your case, do you think it's something that, I mean, subsurface irrigation, do you think it's something that should be tried by someone maybe starting a small farm?
Right. Yeah, I think I missed a bit of it, but going to with your question about the subsurface irrigation system, I've seen it being practiced, but somehow I think when it comes to small scale farmers, I guess it is a bit a challenge because of, again, on the cost of that installation. Practically, I have not done it personally, and I've not interacted with a lot of farmers who are doing it. The only place which I have interacted with them, the person or the people who are doing it, is mostly the large scale farmers. And as I said, it's very efficient. Unfortunately, rather, it requires a considerable installation cost, which in most
Yes.
cases our farmers might not be able to cater for it.
Yeah. Well, we have a question from Diane. Diane, if you can unmute and ask.
Yes. Well, I had a question, but I think I've got also another question from the previous question that was imposed to you, Jack. So if you say that surface irrigation has a limit of it being might be costly. Now, I'm wondering from all the irrigation system that we looked at tonight, what would be a cost-effective irrigation system for smallholder farmers? And the second question was about when would be the best time for irrigating? Because I think it plays a huge part in trying to conserve water. Some people do it in the morning, some people do it in the evening, and some people you find it do it in the afternoon around 3 p.m. I think by then the sunlight is still pleasant as, I don't know. So I think what would you advise people the best time they should be irrigating in way of trying to even to conserve it when there is less sunlight, or is it in the morning or is it in the evening when the sunset is already going down? Thank you.
All right, thanks, Diane. As we all know, it's like a principle for all the small-scale farmers, and not just the small-scale farmers, even the people with adequate amount of water. The plant themselves, they have their water requirement, and they have the best time when to utilize that water. And one of them is very early in the morning and late in the evening. I'll give you an example of a crop like tomato. In most cases, we always say that it's not a myth, but is part of what causes that, by the availability of water. You'll always realize that the blossom end rot, you hear people saying about it is brought about by the lack of enough water, but that's just one. There are others like excessive nitrogen, which hinders the intake of the calcium, and still and the expansion of the fruit. But the tomato plant is very sensitive to the time of water which you apply water in those areas. And if you give it uneven, or rather, how do you call it, uncoordinated watering, whereby today you water in the evening, the other day the next day you water during the day, you realize that problem will persist. But in most cases, the principle is that you are supposed to water your crops in the morning when there is not much sunlight, and in the evening, because as the light intensity or the heat intensity goes up, it means that your crop might get the shock, and some of them might get the scorching effect, which means that that sudden watering when the ground is very hot will be a ground for you wasting water, at the same time not benefiting the crops as required. So yes, it is well advisable you ensure that at least you do watering in the morning or in the evening. I don't know whether I just shared enough information on that.
Yes, you did. You did share enough. And my first question was also about what would be the best cost-effective irrigation system for smallholder farmers?
Well, for smallholder farmers, remember, as I said, it all depends with the availability of water, the amount of water which is within your farm or well in a storage facility. It means that you'll have enough water to do it over the dry period. But even if you have enough, what kind or what suitable method are you supposed to use? And the most ideal is always the drip irrigation. When we talk about the drip irrigation, remember there are those kits. I think in Kenya, there are companies which have capitalized on ensuring that everybody can afford a drip irrigation, whether it is a small scale farmer or the large scale farmer. We have a package of even a quarter an acre, which is cost effective to the farmers and depending on the size of the farm and the topography of the farm. So one of the drip irrigation remains the most ideal for small scale farmers. Yes, there are others like furrow irrigation. I've seen it being practiced. It's very efficient, but at the same time, it requires considerable amount of water. If you are not near any water source and a bigger water source, and where there is no conflict of interest with the people downstream, you can still practice this. And as I said, we all also need to look on the climatic condition. Remember, we are all in the different climatic condition. If you're in a highlands or in the islands where there is enough water, if you do the flood irrigation, it means that your land will be much wet for a longer time, which is a breeding ground for fungal infection. So as we choose, even if we are choosing the most ideal and the most practical part, which most farmers can afford, like furrow irrigation, it also need to look into consideration your climatic condition, whether it is very hot or very dry. If it is very hot, it means that the rate of evaporation is very high. If it is very wet, it means that your land will be more wet and it will bring more challenges to your crops. So I will always go for drip irrigation regardless.
They asked, what can we do for irrigation application methods to meet with varying plant water requirements and varying climatic condition to avoid overwatering?
Well, I think the key word is climatic condition and overwatering. As I said, you can't overwater what is not enough. So one thing is that to ensure that as we look on the type of crop, remember xeriscaping. I talked about the xeriscaping, which is a way of looking deep in what you are growing. The amount of water is not just the amount of water which you are looking at. You are looking at your ground, you are looking at your climatic condition and the water requirement for those crops. You are in a semi-arid areas, and in those semi-arid areas, I'll give examples of vegetables. For instance, you can plant kales in those semi-arid areas, not because it can't do well, but there are some crops which you might do well with a little amount of water than the kales, but they'll give the same value of nutrient as the kales if you are kale lover. We have the amaranths, which do not require a lot of water. We have the spinach, which require little water and which thrives very well in those dry areas. So the amount of water you'll be using on sukuma wiki, or rather, sukuma wiki is a Swahili word, which means
Yeah.
kales, the amount of water which you'll be using on kales, it means that it can grow three crops of amaranth. The water which will be used to grow one crop, it will be used to grow three, which means that you're maximizing as well as looking the water requirement or other needs to those crops. Again, as I said, it all depends with the amount of water which you have. And the word is you can't over-irrigate what you don't have. Again, somehow you might do over-irrigation if you are using the furrow irrigation, which means that a lot of water will be going into waste. So the choice of crop, the climatic condition, and the amount of water available for utilization has to be always be considered before you choose the type of irrigation.
If Jack, if you can give some parting words and then we can call it a night, please.
Okay, thanks so much. Thanks so much, Robert. Thanks so much to Share Screen Africa. Thanks to the host for ensuring this session is most interactive. I'm really honored to be in this forum as a resource person, and I'm looking forward for more collaboration as we try to navigate our ash condition to make them favorable for crop production and make it better for living. We much appreciation from the College of Sustainable Agriculture East Africa for this session too, and we are looking forward for more collaboration. And as I said, the School of West Africa is one of its kind, which teaches the sustainable agriculture, especially in Kenya. You'll see it is one of its kind. So we are looking for more collaboration and looking forward to have more students on exchange programs from your end.
So we thank you very much, Jack, and we call it a night. Thank you.